Today we're going to be looking at lesson 2.06, half interested or more interesting. Today's objective is I can use properties of exponents to calculate interest on a bank account in 1 out of 2 problems. So we'll be looking at interest. Interest is a property of an account that generates more money based on the money that's already in there. So here's some things to think about. What do negative exponents and rational exponents, remember we talked about rational being fractions, what do negative exponents and rational exponents mean in context? And how does the growth factor change if we focus on a month instead of a year? Usually when we get interest rates, they will be on a yearly basis, but can we divide those up into smaller pieces, and what does that look like? So we'll start with a story today. This is Clarita and Carlos. They are twins and entrepreneurs. When they were 10 years old, they started a summer business and they made all this money over here. And their parents suggested they put that money in a bank account. Now the bank account pays 5% interest each year. Remember, that means that the money that's already in there is going to generate more money at a percentage level. So 5% of what's already in there will be deposited in the account just for having it in there. So if they leave it in there until they're 20, it would grow a whole lot. Remember, they put it in there when they were 10. But now they're 15 years old and they're thinking of starting another business. And they're wondering, should we withdraw that money and use it in our new business, or should we let it grow for another 5 years? Should we leave it in the bank and see what it will grow up to? Well, maybe if we can figure out some numbers here, it would help us answer that question a little bit better. What do you think? Do you think they should take it out and invest it in a new business? Or should they leave it in there and let it grow? So if we knew how much they'd have in 5 years, how much the bank account would make, it would probably help us decide so we could know what we were risking, what kind of interest we were risking in the next 5 years. So they pull out a recent bank statement, and it looks like this. So at the end of last year, they had $382.88. If we know that they're making 5% per year, how much will they have in 5 years? Starting with this amount. So Carlos suggests they make a table, and then they just calculate it year over year. So that means we have to figure out what our growth factor is, what we multiply by each time. And we had a shortcut when we used interest rates. Remember, if we had percentages, we would take 1 plus the percentage, and we would need to move the decimal point. So 1 plus 5%. Since it's a percent, we're going to move the decimal point 2 places to the left, so it ends there. And we have to put a 0 in between. So we get 1 plus 0.05. Our growth factor will be 1.05. And I will just multiply by 1.05 at each step. So let's get out our calculator and start calculating those steps. 382.88 times 1.05 is 402.02. Calculate another step, multiply again by 1.05. We get 422.12. Pause the video for a second and see if you can fill in the rest of the table and see if we get the same numbers. We're going to multiply by 1.05 again. And we get 443.23. Multiply again, same number. 443.23 times 1.05 is going to be 465.39. And our last step, multiply by 1.05. We get 488.66. Now I rounded some of those because we're dealing with money, so it always makes sense to round to the nearest penny when we're doing money. 488.66. So looks like they'll make about $100 in interest over the next 5 years. But was there an easier way to do that than filling out this whole table? That was sort of laborious. Took a long time. Took a lot of entering stuff in our calculator. Was probably error prone. We might have made a mistake at some point. Is there an easier way to calculate this out to 5 years? What about 10 years? 10 years would have been an even bigger problem. Or 20 years. Well, we've used equations to make things easier. We know that we're multiplying here, so this is geometric. And we can use the form f of x equals a times b to the x for a geometric sequence. A is our value at 0, that's over here, 382.88. And b is our common ratio, what we're multiplying by each time. Remember, that was 1.05 for our 5% interest rate, so that's our common ratio. We fill that in. F of x is going to be 382.88 times 1.05 the x. So now all we need to do to figure out 5 years is just plug 5 in for x, right? Because years over here are our input values, which are also known as x. So we're just going to plug in 5 over here times 1.05 to the 5 now. And then we put all of that in our calculator. 382.88 times 1.05 to the 5th, I get 488.66. Notice that's the same number we came up with when we went step by step. The only difference is we had to find the equation, but once we did that, we only had one step. We just put in year 5 and we can find the value. If we wanted to find year 20, we could just put in 20 for the exponent, or 100, or any number. And the equation makes it so much easier to get that number. So Clarita says, if we knew how much we put in that first year, we could estimate how much we'd make in our new business. So they could project, based on how much they made in their first business, how much they might make in their second business. But unfortunately, they can't find any older bank statements. They don't know how much they put in that first year. They'd have to figure it out. Can we figure that out for them? Can we help them out? How much did they deposit 5 years ago if they have 382.88 now, and it grows at 5% per year? Well, this is the same function, right? This is where we started. We calculated up. We could just as easily calculate back, right? But now instead of multiplying, we're going to divide by our common ratio, divide by 1.05. So let's see what that is. 382.88 divided by 1.05. I get 364.65. Pause the video, see if you can fill in the rest of those, and then unpause, see if we get the same numbers. So 364.65 divided by 1.05, I get 347.29 when I round. We go up again and divide by 1.05. $330.75. We do it again. Divide by 1.05, I get exactly 315 here, so 315.00. And then one more time divide by 1.05. I get $300 exactly, 300. So it looks like that very first year they deposited $300. And this is how it has grown over 5 years. It grew about $83. And then over the following 5 years, we'd expect it to grow another about $100. Now, once again, we did have to go step by step by step. Is there an easier way? Could we have shortcut that because that took so long, it was so annoying to do? Sure. So we can input this value again into our x. If we just put that value into x, we should calculate it for the year -5. So I'm going to put -5 in for x and see what we get out. So we have 382.88 times 1.05 to the -5. I put that in my calculator and I get 299.996, which rounds up to 300. Get the exact same thing we got up here. So we can use the equation that we already figured out as a shortcut to go back 5 years, or to go forward 5 years, or any number of years. So Clarita thinks they could easily make $500 with their new business. Remember, we projected they'd have about just under $500 in another 5 years. So Clarita thinks if they start a new business now, they could easily make that, and they should withdraw it now so that they can reinvest that money, and that can start making more interest. But Carlos has a concern. Carlos responds, but we're halfway through the year. Are we going to lose half a year's interest if we withdraw it right now? Well, how would they figure that out? They actually have to call the bank and find out the terms of their savings account. And the bank fortunately tells them that if they withdraw now, they will get half a year's interest. So that's nice. That's a good thing the bank did for them. But how would we know how much they can expect at half a year? How can we find how much interest they would make half a year from now, or half a year from the beginning of this year? What is the value here at half a year? Well, just like with 5 years in the future and -5 years, 5 years in the past, we can just take this x value and put it in for x. So f of 1/2 is going to be 382.88 times 1.05 to a half. Another way of writing this you may recall from our exponent rules anything to the 1/2 is going to be the square root of 1.05. We take the denominator and we make it the base of the root. So this will be a 2 root, also known as a square root of 1.05. So we can plug that into our calculator and just figure out what it is. 382.88 times root 1.05, I get 392.34 when I round. So 392.34. They make about $10 in half a year's interest. Notice what we multiplied by here was this root 105, or root 1.05 rather. We took 382.88 times root 1.05, which is going to be our multiplication factor for each of these steps. Root 1.05. Or we can put that in our calculator and get a number. That's approximately 1.0247. So we could call that our multiplication factor if we wanted to. Multiply by 1.0247. So if we wanted to find all these individual half years, that's all we'd need to do, multiply by 1.0247. Or we can use the function. So let's take a closer look at these growth factors. We said that 1.05 was our growth factor for the whole number when we're jumping by whole years. So we went from zero year to 1 to 2 to 3, and we multiplied by 1.05 because the percentage interest rate was 5%. Now switching back to words, what this means in context, what this meant in our story, is each year the money is in the bank account, the account balance gets multiplied by 1.05. That's the same thing we did in our calculator, right? We just typed in multiply by 1.05 and we got the next year. Multiply by 1.05, get the next year. This is another way of saying each year the account balance increases by 5%. So a multiplication factor of 1.05 is the same thing as 5%. We're just going in the other direction now. We say 1.05 minus 1, right? Because we added 1 to the percent, we get 0.05. Then we move the decimal 2 places to get to our percent. We get 5%. That's where that came from. So multiplication factor of 1.05 means a 5% interest rate. So now what if we add these half years back in? Well, our number, our multiplication factor is going to change. We said that was root 1.05, or about 1.0247, same thing. So let's talk about what that means in terms of words. Some time period, so for every time period here, the account gets multiplied by something. So what are we increasing by each year step over here? Looks like we're increasing by a half year, and then another half year, another half year, and half year. So each half year, the account balance gets multiplied by, well, we're multiplying by 1.0247. 1.0247. Notice that number is different than when we were going by a whole year. That makes sense because we actually need it to be 1.05 when we do 2 steps. So each half year, the account balance gets multiplied by 1.0247. And that is the same thing as saying each half year, the account balance increases by what percent? So what percent is equivalent to this multiplication factor? So we do the same thing we did before. We do 1.0247 minus 1. We get 0.0247. We're going to move the decimal point 2 places and call that our percentage, 2.47%. So every half year, the account balance increases by 2.47%. We figured out the percentage rate for a half year. They told us initially that the percentage rate for a full year was 5%. The percentage rate for a half year is 2.47%. Notice this is not exactly the same as 5 divided by 2, 5% divided by 2, which would be 2.5%. It's not the same. That's because this is compounding interest. That means the interest that we made in the previous step gets interest applied to it on the next step. So it's growing a little bit faster. So here's our original equation. 382.88 times the original 1.05 interest rate. If we want to emphasize the half-year growth rate, we can use exponent rules to rewrite the equation. So what we've done here, we've raised it to 1/2 and raised all of this to 2x. Well, we know that an exponential raised to another exponent means we have to multiply these. So let's see what that becomes. We get, and I'm just looking at the exponents now, I have 1/2 times 2x. Well, that's going to be 2 over 2x, and 2 over 2 is 1, so this is just x. This statement right here is the same thing as this statement. These are equivalent equations. But we've separated it out so that we can see the half-year interest rate. Remember, this was the half-year interest rate we calculated in that previous step. And we can actually resolve that, right? We put that in our calculator and get 1.0247. And these are, again, equivalent equations, but this one emphasizes now the half-year interest rate instead of the full-year interest rate. There's an implied 1 here that tells us one year. This tells us we're dividing the year in 2. So this is the interest rate we would get over half a year. So all the expressions below represent an annual interest rate of 5%. So we have that same old 1.05 base, but they've been written to emphasize the quarterly, monthly, or daily interest rate. And they're asking us to identify the time period and the percentage interest rate for that period. So let's look at this first one. 12t, 1 over 12 and 12t. Remember, if we multiply these, we'll get 12 over 12, which reduces to 1, and it'll just go away. What does this number imply about the time period? We know there are 12 months in a year, so this is going to be a monthly interest rate. And now I just put the value inside the parentheses in my calculator. 1.05 to the 1 divided by 12. I get 1.0041, if I round, to the 12t. This tells me that this is my growth factor monthly. To get the percentage out of that, I'm going to subtract 1. I get 0.0041. Move the decimal place twice, and I get 0.41% monthly. So we can do that really for any period that we want to divide a month or a year into. We divided a year into 12 months. What about 4? What would that be? What would we call that if we divide a year by 4? We call these quarters usually, so this would be quarterly interest rate. And 1.05 to the 1/4 is going to be 1.0123 approximately. We turn that into a percentage. We remove the 1, move the decimal twice, and we get 1.23% quarterly. I did that last step pretty fast. Let me walk you through that. We did 1.0123 minus 1. We get 0.0123. Move the decimal. That becomes 1.23%. And the last one here, 365, well, this tells us it's going to be daily, 365 days in a year. So we're going to calculate what's inside the parentheses, 1.05 to the 1 divided by 365. Now, if we think about this, this should be pretty small, right? The daily interest rate should be pretty tiny. We get 1.000133. Let's just say 13. To the 365t. So we're going to take the growth factor minus 1. We get 0.00013. Move the decimal 2 places. We get 0.013% daily. That is super tiny, but over time it still adds up to 5% yearly. So that's how we can split up a year into smaller chunks of interest rates. So that covers everything for today.